చెప్పండి. చూడండి మనం చేస్తారు కదా, ఇంట్లో ఉన్నారండి క్వారంటైన్ చెప్పాను కదా. అవును సార్, ఎన్నిసార్లు చెప్పండి. అవునవునండి. అవునండి. ఇంట్లో ఉన్నది క్వారంటైన్ లో. Hello. Yeah, are you hear my voice? Hello.
Yes, sir.
Yeah, I think my voice is audible.
Sir.
I say.
Yes, sir.
Yeah. So today our topic is silicon control rectifier. SCR is a three-terminal, four-layer, three junctions device. So it is a three-terminal, four-layer, and three-junction device. So a PN, a PN junction is in series with a PN junction, PN, PN. This is the four layers we can form, or we can say that a PNP transistor and an NPN transistor are connected back to back, so that we can form a SCR. We can say like that also. A PNP transistor and an NPN transistor connected back to back, so that we can get the PNPN device. It's called as a silicon control rectifier. So it contains four layers, PN, PN. So like this, I have to form. And from these four layers, we'll take out three terminals and three junctions. I think formed because between this PN, PN, P terminal and N terminal, one junction is formed here, and between this N and P, there is another junction is formed J2, and this is from P and N. Another junction is formed. This is called as J3. So J1, J2, J3, three junctions are formed, right? And a four-layer device. So how to construct this? This we will see. So to construction, coming to the construction. So this construction will contains generally a germanium or silicon terminal is taken. Semiconductor is taken. Germanium or silicon semiconductor is taken according to the requirement. So here I need first P layer, right? After that, so to make the P layer, a traveling impurity is added up to this region, right? And followed by this one, an N region is formed. So to form the N region again, I have to make this is a pentavalent impurities. Again, a P region, again an N region. Not this much, only up to this. Okay. So this is the construction, a PN device formed. So from P terminal, P region, and again an aluminum foil is placed here. An aluminum foil or aluminum metal is placed. From this, an aluminum lead is taken out. So this is called as anode. This is called as anode. Okay. Right. And in the bottom, here from the N region, again an aluminum metal is placed here. Right. From this, aluminum rod is taken out. This is called as a cathode. Right. So in between, see here, just like what we told here, one PN junction, one PN regions, or junction is formed. So PN junction, this is called as junction J1, and this is called as junction J2, and this is called as junction J3. So three junctions are formed, right? So from the third junction, from this P material, Again, an aluminum foil or aluminum metal is placed here, right? And from this, and another terminal is taken out. This is called as a gate. This is called as a gate. So now we can say that a PN region, right? A four-layer semiconductor, and between these four layers, three junctions are there, and three terminals take it out. One is anode, and the second one is cathode, and third one is the gate, right? So this in this one junction J1 and J3 operates in the forward bias. J1 and J3. These two are operates in forward bias. These two are operates in forward bias. Whereas junction J2 operates in the reverse bias, reverse direction, right? So junction J2 is operated in the reverse direction, whereas junction J1 and J3 are operated in the forward direction or forward bias, right? This is the constructional diagram, right? So the constructional diagram consisting of four layer of PN regions, or we can say that PN regions or get together or sandwich together so that we can form a SCR. So from this SCR, it contains three junctions J1, J2, J3, right? And three terminals are anode, cathode, and gate. And the symbol for this one is simple a diode symbol, but gate is represented in different way, right? So this is the cathode, this is anode, and from this junction, just we are placing like one terminal called as a gate. So this is the symbol, right? Symbol for SCR. So simple a diode and the extra gate terminal is taken on. Right? This is a symbol for a SCR. Right. Next is the how to operate this. What I told, this will be constructed by using a PNP transistor and NPN transistor. This forms a one PNP. This forms one PNP transistor. Is it not? And this forms a another NPN transistor. Right. So the blue color here indicating a one PNP transistor, and this green color indicating an NPN transistor. These two are clubbed together, right? How to club these two? So that an SCR is how the SCR is formed. So SCR using two transistors. SCR using two transistors. SCR using two transistors. How these two transistors are connected here, right? So I'm taking the same one is a blue, right? So a P, N, and P. Right? Similarly, here is one LED is taken out. This is called as anode, right? This is another transistor is indicated shown here is a green terminal. This is resistor T2 చేస్తాం ఎందుకంటే okay, so these two are combined so that these two are combined, so రెండింటిని ఇలా క్లబ్ చేయడం వల్ల మనకి this is forming a SCR, right? So this is the transistor method for this transistor. What is the circuit for this transistor? So coming to the circuit, one is a PNP transistor. So what I have to do? I have to use one PNP transistor, right? So what is the indication for the PNP transistor? We have to show an arrow mark towards the inside. This indicates the PNP transistor. So this is the base terminal common, this is the emitter, and this is the collector, right? And this collector of this one is which is the time transistor is a PNP transistor, right? So P region, N region, P region. So this P region is connected to the N region of the base. This P region is connected to the N region of the base. This P region is connected to the N region of the base. So what I am doing, I am taking this connected to the another transistor base. So this is the transistor of NPN. So arrow mark is shown outside. Is it not? And this base is connected to the collector of this one, right? This base is connected to the collector of this transistor. So this is T2 transistor, this is T1 transistor, right? And in between we have to apply the bias. Voltage of V. So this is emitter E2, B2, and C2. This is B1, E1, and C1. So this the voltage is called as gate voltage VGG, and this voltage is called as anode voltage VA. Or which anyone can call IC2. This base current is equivalent of the collector current of transistor 2, right? So this is the PNP and this is the NPN transistor. NPN transistor, right? So this is the circuit diagram showing the two transistor model. Okay, this is the construction part. Now, how to run this SCR? How to run this SCR? How operation? You can call it. Now I have shown only the construction diagram, right? So this is the one construction diagram which is using the general original or general silicon controller, right? And with the help of two transistors, how we can construct the SCR, and what is the equivalent circuit for this one is this one, right? Now we will go through the operation part. Right, SCR operation. SCR operation. So to operate this SCR, we have to apply a anode voltage and a gate voltage. So two ways we can operate. One is the
సార్ మీ వాయిస్ కట్ అవుతుంది సార్.
How is the voice now? Hello. Is
Yes,
the
sir.
voice is audible
Now
now?
it is clear.
Yeah.
Yes, sir.
Yeah. So So now an anode voltage is used here. So a voltage of positive voltage is connected between the anode terminal and the cathode terminal. Right? Right? If you take a constructional diagram part, you can take constructional diagram by using the P, N, and the P and N. So there is a gate here, and there is an anode here. So a positive voltage of is applied. This is called VA. Right? Here 0 volts initially. So how it is operate? So when SCR is in forward bias, so anode is connected to the positive terminal of the supply voltage, and negative is connected to the cap, right? So that the SCR is in the forward bias. So when this voltage is applied, immediately the diode is the SCR is not switched on. So ఇక్కడ SCR ఆన్ కావడం అంటే SCR fire అని అంటాం, right? SCR fires అంటే SCR is switched on. The meaning of this fire means switched on. So here we have 3 junctions, right? J1, J2, J1, J2, and J3. So what I told, J1 is P is connected means this junction is forward bias according to the theory, diode theory. Is it not? P is connected to the positive terminal, N is connected to the negative means this junction J1 is forward bias. Similarly, when junction J2 means, which internally this junction J2 is N is connected to the positive, right? So this junction J2 becomes reverse bias, right? Whereas junction J3, N is connected in this PN junction, the N is connected to the negative, right? So that we can say that the junction J3 is reverse forward bias. So junction J1 is forward bias, junction J2 is forward bias, junction J2 is reverse bias. So even when J1 is forward bias, the conduction is not possible here, right? The conduction, the current, what is the current flowing here is anode current IA. IA is not flowing here because the junction J2 is reverse bias. At the same time, junction J3 is forward bias, but no question of conduction here. Just it is connected in forward bias mode, but no question of any particles are diffused here because junction J2 is reverse bias. ఈ రెండింటి మధ్యలో జంక్షన్ J2 అనేది రివర్స్ bias అయింది కాబట్టి ఇప్పుడైతే జంక్షన్ J2 బ్రేక్ డౌన్ అవుతుందో, when the junction J2 becomes breakdown, then these two junctions will become forward bias. So enormous amount of current is flowing. So then we can say that there existing the SCR is fired. We can say that the SCR is fired. So what voltage we are applying VA means almost the VA is greater than or equal to 200 volts. Greater than or equal to 200 volts if you apply, then only the SCR is fires. Otherwise, if you simply apply a 10 volts or 30 volts, the SCR doesn't fire here because junction J2 is reverse bias, because junction J2 is not directly connected, right? It is internally connected. So internally connected means how much of voltage required in this PN junction to this in this junction J1 to make this junction J2 becomes reverse bias. If it is directly connected to the supply means we can say, we can judge this much of voltage required to make this junction is reverse bias, but which is not directly connected, which is indirectly connected, junction J2. So therefore a lot of enormous amount of voltage or more voltage is required to make the junction J2 becomes breaks down. More voltage, and the voltage more than 200 volts. Sometimes some ACRs may require it is more than 400 volts also. Some ACRs may require more than 400 volts. So this this is without VGG voltage. Gate voltage becomes 0. Right? This is the one type of operation. So first operation is when VGG is equal to 0 volts and VA is applied. This is the first operation. So what is the VGG 0 I am making, right? I am not applied any voltage here. So therefore VA voltage is applied. So VA voltage goes on increasing. I am increasing the voltage 10, 20, 30, 40, 50 goes on, I am increasing. So at one particular voltage of reverse VA voltage, right, junction J2 becomes breaks down. When the junction breakdown means, so the enormous amount of anode current is flowing into the SCR. flowing into the SCR. Then we can say that SCR is on or SCR is fired, right? So that is the way you have to explain the first operation. Only by application of anode voltage. Only by the application of anode voltage, right? Simultaneously, I will go through the characteristics also. I will go through the characteristic part also. VA characteristics. So these VA characteristics are drawn between VA characteristics. So these characteristics are drawn between the anode current IA and anode voltage VA, a forward voltage VA, VF or VA. Elan coach. We can call it VR, VF. A anode voltage VA, right? So initially, what I am saying, the voltage V is 0. Now the voltage is slowly increasing here. When the voltage is slowly increasing here means there is no question of, but there existing some reverse current is there, right? Because junction J2 is reverse bias. There is some microamp current is flowing here. So the current is indicated by a small amount of current here. Just a minute. చెప్పండి ధవలా చెప్పు ధవలా గుడ్ మార్నింగ్ 412 ఆమె ఫీజు పే చేసింది ఫామ్ ఇవ్వలేదు ఆమె ఫామ్ ఇవ్వలేదు నాకు పేరెంట్ రాసుకుంది ల్యాబా అవును కరెక్టే ఆమె నాకు సెండ్ చేయలేదు ఆ అబ్బాయి కూడా నాకు సబ్మిట్ చేయలేదు ఆ అమ్మాయి అయితే ఫీజు పే చేసిందంట 412 అంటే ఇంతకుముందు అట్లా కాదు వాళ్ళు వసతి దీవెన కింద రావట్లేదు వసతి దీవెన కింద వాళ్ళు లేరు లాస్ట్ ఇయర్ ఏదో ఉన్నారంటే ఈసారి వాళ్ళు కాలేజ్ వాళ్ళు బయట అవుట్ అయినారు అయితే ది పేడ్ ఫీజు 4K కూడా వాడు కూడా సేమ్ పెయిడ్ ఫీజ్ పెయిడ్ నాట్ ఎలిజిబుల్ నేను పెట్టిన వాళ్ళలో 8 మంది పెట్టాను కదా వాళ్ళలో 7 మంది ఎలిజిబుల్ ఒకడు ఇంకా నాకు ఎలిజిబిలిటీ వస్తుంది సార్ వెయిట్ చేస్తున్నానని చెప్పాడు ఏమి నేను చెప్పేది ల్యాప్టాప్దే చెప్పేది ల్యాప్టాప్ నాకు పంపించింది ఓన్లీ 7 మంది మాత్రం పంపించారు అందులో ఒకడు ఆ 7 మందిలో ఒకడు మాత్రమే ల్యాప్టాప్ కావాలని పెట్టాడు మిగతా వాళ్ళందరూ ఇంకా 8 మంది నా దాంట్లో మొత్తం ఉండేది అయితే మిగతా వాళ్ళందరూ ఫీజు లేదు వాళ్ళకి వాళ్ళు మామూలు కట్టేశారంట వాళ్ళు ఆల్రెడీ పెయిడ్ ఫీజు ఒక పిల్లోడు వాడికి నేను నాకు ఫీజు ప్రాసెస్ లో ఉంది సార్ అంటున్నాడు కానీ వాడు ఏం సబ్మిట్ చేయలేదు ఫామ్ కూడా నాకు వాడికి అంటే నేను దాన్ని రాశాను అండర్ ప్రాసెస్ అని పెట్టాను చూడు ఒకటి పెట్టాను అండర్ ప్రాసెస్ అని 448 పెట్టాను చూడు 448 అండర్ ప్రాసెస్ అంటే వాడు ఫీజు పే చేశాడంట కానీ వసతి కింద వాడు అప్లై చేసిన అండర్ ప్రాసెస్ అని చెప్పాడు అంతే మనకి వాడి ఫామ్ కూడా నాకు సబ్మిట్ చేయలేదు ఇంకా హిమేష్ 448 కూడా 4K కూడా నాట్ ఎలిజిబుల్ వాడు పే చేసేసాడు ఆల్రెడీ 448 అబ్బా నెంబరు ఆ పిల్లోడు లేదు ఆ పిల్లోడు ఏం ఇన్ఫర్మేషన్ లేదు ఆ పిల్లల గురించి ఆ ఫీజు కూడా పే చేసినారో తెలియదు వాడు. వాడిని ఫోన్ పోవట్లే ఉంది, నెంబర్ ఐడియా లేదు. వాడు లేడు, ఉంటే ఎలిజిబిలిటీ ఉంటే పెట్టేవాడు కదా. ఎలిజిబిలిటీలో వసతి అనే దాంట్లో ఎలిజిబిలిటీలో లేడు వాడు. రైట్, అంతే. హలో, యా యా, ఆర్ యు హియర్ మీ? Sorry for disturbance.
Yes, sir, we can hear you.
Yeah. So, so VA is applied. This VA voltage will make this junction J1 and J3 forward bias, but junction J2 is reverse bias. So small voltage will not turn up. The junction J2 is breaks down. So heavy voltage is applied. So under this process, what I am saying is J2 is having some reverse current is flowing here. The reverse current I am representing as like this. This is the amount of reverse current. So in this reverse current is there, right? Some amount of current is there. That is current is due to the reverse current of a junction J2. But there is no enormous amount of current is flowing in the SCR. As you increase the VA, anode voltage goes on increasing. No question of increasing the current. So it goes up to some point, right? So after reaching some voltage point of a supply voltage, maybe it is a 200 or a 400 volts, then the junction J2 becomes breakdown. When junction J2 becomes breakdown means, right, immediately the applied voltage will fall down, will come down, and the current is goes on increasing. The applied voltage is decreased. This applied voltage is automatically will come down. Then the current is also increasing, right, and it goes to further increases. It goes to further increases, right? So what up to what voltage this is happened? At what voltage this is happened? This is called as a VFB. VFBO, right? Break over forward break over voltage. VFO means forward break over voltage. Forward break over voltage. So it is the maximum forward voltage applied on the SCR. At what voltage of this maximum forward voltage the SCR turns on or fires, right? SCR turns on or fires. Then that voltage is called as a forward breakpoint voltage, right? Under this, after reaching this VFPO, then immediately the forward voltage or anode voltage will get down, comes down or come down to a minimum value, and up to what voltage this voltage is called as a forward blocking region. It's called as a forward blocking region. So up to this region, no question of conduction here. That's why it is called as a forward blocking region. And when this voltage comes down at this voltage, then we can say that the current is slowly increases, linearly increases. Right? This is called as a conducting state. Or SCR is on. SCR is on. Right? And at what voltage this happened? This is called as a holding current. This is called as a holding current, right? This is the maximum whole current is hold continuously, right? When the SR is on, then from that as the voltage is slowly increases, then the current is also increases linearly, right? So that is a happen in the junction J1 using junction J1 J3, right? And suppose in the forward bias it is a heavy voltage required, right, to get the VFB. Breakover voltage, breakover region is reached, breakover voltage is reached with a heavy voltage. So what voltage VA is greater than 200 or greater than 400? Okay, 200 to 400 madhya voltage is required to get this breakover voltage. So in the general laboratory, electron laboratory, this much of voltage application is very difficult, right? So that's why what we are doing, we are now applying a small amount of gate voltage. The second method of operation is a small amount of a small gate voltage VGG is applied. A small VGG voltage is applied. So this small voltage will make this PN junction, this junction J2 is somewhat makes the forward bias. Somewhat will make the forward bias. So when the junction is somewhat makes forward bias means it is easy to overcome the breakdown breakover breakover voltage process from junction J1 to junction J3. జంక్షన్ J1 నుంచి జంక్షన్ J3కి మనం ఈజీగా టర్న్ అప్ కరెంట్ ఫ్లో చేయాలంటే ఐఎమ్ అప్లయింగ్ దిస్ జంక్షన్ J2 ఈజ్ స్లైట్లీ ఫార్వర్డ్ బయాస్. రివర్స్ బయాస్ అవుతుంది ఈ వోల్టేజ్ వల్ల, బట్ ఇక్కడ గేట్ వోల్టేజ్ వల్ల ఐఎమ్ మేకింగ్ దిస్ జంక్షన్ J2 ఈజ్ సమ్వాట్ ఫార్వర్డ్ బయాస్. ఎక్స్క్యూజ్ మీ, హలో ఎవరండి? నీ నెంబర్ ఎంత, రోల్ నెంబర్ ఎంత? అవును పర్లేదు, మరి నువ్వు నాకేం పంపించలేదు కదా ఫామ్, అది ఫిల్అప్ చేసి. అవును నాకేం చెప్పలేదు కదా, నాకు ఓన్లీ 100% పెట్టావు, నేను కూడా అదే ఇన్ఫార్మ్ చేశాను. నువ్వు అది పడిన తర్వాత చెప్పండి మీరు. ప్రస్తుతానికి అయితే మీరు ఆ ఫామ్ పంపించి ఫీజు నాట్ పెయిడ్, శంషీర్ దౌలా సార్ ఫోన్ చేసి ఫీజు నాట్ పెయిడ్, శంషీర్ దౌలా నెంబర్ లేదా మీకు? సరే నేను కాల్ చేస్తాను లేదు. నువ్వు ఎప్పుడు వస్తుంది? 9th వస్తుందా? 9 రోజులు పడుతుందా? అవును మరి నాకు ఇన్ఫార్మ్ చేయాలి కదా, నేను నుంచి మెసేజ్ పెడుతూనే ఉన్నాను గ్రూప్లో, ఎవరు రెస్పాండ్, నువ్వు అసలు రెస్పాండ్ కావడంలే. అదే 100% పెట్టావు నువ్వు అంతే. మరి ఇదేమో కావాలంటున్నా నువ్వు అది ఫామ్ అన్న పంపించింటే నాకు సర్లే, నువ్వు ఫీజు పే చేయలేదు తర్వాత పే చేస్తానని రాసేవాడిని. ఫామ్ కూడా పంపించలేదు అంటే నువ్వు ఏది ఆఫ్ చేస్తున్నా నాకు ఎట్లా తెలుస్తుంది? నువ్వు ల్యాప్టాప్ కావాలన్నా లేదంటే అమౌంట్ కావాలన్నా నాకు తెలియదు కదా. ఏమో మరి పంపిస్తే నేను చెప్తాను దౌలాకి. Hello. Yeah. Lot of disturbances coming, right? So now I am applying a small gate voltage VGG is applied. Yeah, are you hear me?
Yes, sir.
Yeah. A small gate voltage VGG is applied here. Now take a small gate voltage which makes the gate junction is forward bias. Which makes the gate junction is forward bias. So here I am applying a small gate voltage which makes the small forward bias. Right? So అప్పుడు ఏం జరుగుతుందంటే immediately instead of going this breakover block region to up to this voltage, it immediately turns off. ఇక్కడెక్కడో టర్న్ అప్ అవుతుంది. Now it comes down. ఇక్కడెక్కడో టర్న్ అప్ అంటే the breakover voltage is decreased from here to here. అంటే early I can reach the SCR is 5 with a small amount of anode voltage or forward voltage. Earlier I got 200, now I got 50 volts. So up to 50 volts I can reach the breakover region, right? This is the breakover region. So breakover region is very early reached and the current is increased. So this is also one way of SCR is on. This is called when VGG is equal to is equal to 0, and this is when VGG is applied, right? Small voltage, maybe it is a 2 volts or a 3 volts. Maximum of 2 to 5 volts madhyane undali. This range is 2 to 5 volts, not more than 5 volts, right? Maybe 1 volt or 2 volts is enough to make this junction J2 forward bias. Are you clear now? So this is the two ways of operation. One is the when VGG is equal to 0 and when VA is applied, and second one is when small VGG voltage is applied along with the VA. So this way we can operate forward bias. This is a forward bias operation. So when VGG is equal to 0 means heavy breakover voltage is required. When small amount of gate voltage is applied, the breakover voltage is decreased, right? And it comes down. And what amount of current holds when the SR is on? What amount of minimum current is hold when SR is on? That is called as a holding current. Minimum forward current when the SR is on is called as a holding current. It is the maximum forward voltage applied to get the breakover region. The voltage is called as a breakover voltage. So this is the more definitions are very important because this may ask in the examination for a 2 marks or 1 mark. Right. Next, coming to the reverse bias. In the reverse bias, same anode is connected to the negative, right? Anode is reverse. This is forward bias. And coming to the reverse bias, in the reverse bias, same thing. PN. So this is the reverse bias and this is the forward bias. VA anode voltage, and the gate voltage is the VG. So when this voltage anode voltage is applied, reverse voltage is applied, so automatically junction J1 and junction J3 are reverse bias. So under this reverse bias, and heavy amount of reverse saturation current is flowing here, and it will be there, right? It will be there, right? At one particular reverse voltage, as you goes on increasing the reverse bias on this junction, so immediately at one particular voltage called as a reverse breakdown. Reverse breakdown is occurs. I think you know what is breakdown, right? This is called as a VRBO. So VRBO means reverse breakdown voltage. Reverse breakdown voltage, and this is called forward breakover voltage. So it is a maximum reverse voltage applied on the SR. At what voltage of maximum voltage the SR is breaks down, and the region is called as a reverse blocking region. Reverse blocking region, and the current is called as this current is called as a reverse leakage current. I know it's called as a reverse leakage current, right? This will be present. So this is the VA characteristics of a SCR. This is in forward bias, and this shows in the reverse bias. And these are the two important definitions: forward breakover voltage, reverse breakover voltage. Right? As the gate is 2 volts, next gate is becomes 3 volts means this becomes like this. ఇంకా ఎర్లీగా మనకి బ్రేక్ఓవర్ రీజన్ వస్తుంది. ఇక్కడ ఫార్వర్డ్ బ్యాస్ లో మీరు అప్లై చేసినప్పుడు 1 వోల్ట్ పెంచి ఇలా వస్తుంది. దిస్ ఇస్ 1 వోల్ట్ and this is the 2 volts and this is the 3 volts. So like this, as increase the gate voltage, breaker voltage is very fastly reached. Hello, చూడండి అమ్మ తర్వాత చేయండి అమ్మ క్లాస్. Right, so this is about the SCR. We can operate this SCR in 3 2. The third one is a reverse base. reverse bias. So in the forward bias, we can operate when gate is 0 volts and VA is applied, and second operation is when a small gate voltage is applied and VA is also applied, right? And when in the reverse bias, VA is negative, VA is equal to negative, a reverse voltage is applied. So like this, three ways we can operate the SCR, right? And this is about the operation. Next, coming to the last topic here is solar cell. Are you clear? Any doubts here? You can ask. Any doubts you can ask. అర్థమైంది అందరికి? అందరికి అర్థమైందా?
Yes, sir.
Or any doubts? You can raise the doubts. And the last topic here is the solar cell. The solar cell is nothing but a PN junction diode, right? A solar cell is nothing but a PN junction diode. I think we know about the PN junction diode, right? PN junction is there, in between a junction is formed here, is it not? Right? And on this junction, but here the junction is reversely connected, right? The two terminals are taken out, two leads, this is anode and this is cathode. RA, cathode, RAN, this is P. Simple PN junction, right? So the solar cell generally just like a photodiode. You know what is a photodiode? We studied. A photodiode means the junction is photoconduction phenomenon is applied. The junction is coated with a photomaterial. A light intensity is fall on this junction, on this one. Then there existing a conduction is possible, right? Electron hole pairs are formed. The electrons are moving, and the conduction is formed here. In the same way, here we are applying some light here. Which light is fall on the junction. A light is light, right? A light is applied on the junction. Then the reverse bias on the junction is goes on increasing. Reverse bias means you know very well the potential barrier is goes on increasing here, right? From here and here, this potential barrier increased here. So right. So at the same time, the electron hole pairs are formed, right? Nearby the junction, the electron collide with the electron hole pair, and this electron hole, the covalent bond is break down, and this break the covalent bond will release one electron, free electron, and one electron hole pair. Or simply you can say that hole. So ikkadento jarugutante in this solar cell lo, the holes which are generated here and electrons which are generated in this junction, the electrons all are moving towards this side, and the holes are electrons are moving towards this side and are accumulated at one point. So ikkada accumulate అయిపోతాయి అన్ని all electrons are accumulated. Ikkada all holes will be accumulated. All holes are accumulated. But the same PN junction diode లో మనం ఏదైతే మెటీరియల్ యూజ్ చేస్తామో ఆ మెటీరియల్ యూజ్ చేయం ఇక్కడ. There is a separate materials are there. Just like photodiode లో మనం ఏం చెప్పాము, LED లో gallium nitrate, gallium phosphate, such type of materials or photo materials are used like this. Here also there are different materials, not a simple PN diode, but junction is a simple PN, but N is formed with a different materials and P is formed with a different materials. And the phenomenon of these materials are such that whenever the covalent bond is break down here, the holes are move away from the junction and electrons are move away from the junction and move towards the N region. Here holes which is move towards the P region and are accumulated here, right? This accumulated holes and these electrons, now what is the balance condition? All these whole electrons are come and fill these holes, then the PN junction becomes neutral, is it not? All these generated electrons ఏవైతే ఉన్నాయో ఇవన్నీ మళ్ళీ ఏం చేయాలి, ఇక్కడికి వచ్చి ఈ హోల్స్ ని ఫిల్అప్ చేసేస్తే then the PN junction become neutral కదా. కానీ ఇక్కడ ఇది న్యూట్రల్ గా లేదు, ఇక్కడ మోర్ నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్, మోర్ నెంబర్ ఆఫ్ హోల్స్. So I complete this path. I want to complete this path. What I'm doing, I'm connecting a light here. I'm connecting a bulb. I'm connecting a bulb here, right? I'm connecting a bulb, right? So this bulb will glow. Through this and fill the hole. As far as the electrons are coming and falling, and this bulb is continuously glowing. This bulb is continuously glowing, right? So if the accumulation is not there, what happened here? If accumulation lekunda bulb rakunda, if I connect directly a wire to here, right? Wire తీసుకొచ్చి ఇలా కనెక్ట్ చేశాను అనుకోండి, at the time also the electrons are moving and complete the fill these holes. So అప్పుడు ఏమవుతుంది, no question of any voltage are generated here, right? But there existing a reverse current. How much of the reverse current is formed here? That reverse current is generated. So when you come to the VI characteristics, this is the voltage and this is the current I, right? So when it operates as a simple normal diode means it goes like this, is it not? It goes like this. Forward bias characteristics of a diode, and in the reverse bias of a diode, it comes like this, is it not? We are reverse. So this current is I naught is present here. So the solar cell will operate in this region. This is the characteristics, right? Solar cell will operate in this region. So this is the maximum, I maximum here, I maximum, and this is I is equal to 0. I maximum ఎప్పుడు వస్తుంది? When more and more electrons and holes are accumulated on one side, so maximum current is generated, right? So more and more light fell down on this one junction region. So more and more electrons and electron hole pairs are generated and they are separated and move across like this. So this electrons moving like this and fill the hole. So the maximum current is generated here at this point, right? So మనం bulb connect చేసినప్పుడు only the light will glow. We can measure the maximum current only, right? Suppose instead of using a bulb, if I connect a resistor, what happens? If I connect a resistor here instead of a bulb, so how much of voltage drop generated across this resistance, right? P and N. Here is the holes are accumulated, here is the electrons are accumulated. So how much of voltage drop is created, so that we can say that this PN junction will generate that much of voltage, or the solar cell will generate that much of voltage. So if I vary this resistance, so automatically voltage will also vary, right? So for maximum current I get here, if I goes on vary the resistance means the next current is decreased here, the next point is decreased here, the next point is here, next point is here. So if I get maximum resistance, or simply maximum resistance, I get maximum current here. So if the resistance goes on decreasing, then finally it becomes a short circuit and I becomes 0, right? I becomes 0. This is the region of operation. So like this, I can vary the current by using a variable resistor here. Or simply instead of using this one, if I place a cell here, a voltaic cell, if I connect a voltaic cell, so how much of the voltage stored this cell? How much of the voltage stored this cell? So that can also we can measure, right? This is called as a voltaic cell. This is called as a voltaic cell. So how much is the current is generated here? That much of current is flowing, and it will develop a voltage drop, and that voltage drop is V. Like that also we can say, right? So this is a simple way we can explain a simple solar cell. There are many different types of solar cells are there, but this is one of the kind of solar cell we can use for regeneration, right? So the representation for the solar cell is just you keep a diode and keep a circle, and light ray will fall at the junction, right? Just same as the photodiode, right? Same as the photodiode. But Voltaics, this solar cell is different here in the way the material which you are using here. Photodiode we can just coat it on the junction. Photo material is coated on the junction, but the material here, solar cell material is taken. P material and N material is different here. The solar materials, not ordinary PN materials, right? So the phenomena, the characteristics of this is to make the electrons and holes are separately. That is the main process. So based on this, the solar cell is operating. So this is a kind of region where finding the VA characteristics. If a simple operates a simple PN diode means we can operate. We can operate a reverse bias PN junction means we can operate, and I0 is generated. And in between these two, a region called as the solar cell, solar region. In this solar region, we can operate. We can operate the PN junction, right? So this is the simple VA characteristics. So that's all. This completes the total syllabus of the EDC, right? If you have any doubts, you can raise and you can ask. I think I complete the total syllabus. If time permits, we'll go through some problems on biasing. I think I did more number of problems. Again, still we'll go further problems in one class. Are you hear my voice? Hello.
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
So this is the complete chapter, 5th chapter, and one more announcement here is we are going to conduct a laboratory examinations. We are going to conduct a laboratory examinations, and this laboratory examination is done under online, not offline.